like we said, we will try and go ahead and look into the user story number one. It says that as a librarian, I want to see all books borrowed within a chosen date range to track usage. So we have select b dot title, and here this gives us the count in for the book ID on the borrows table br as a new variable total borrow count, for example. And from the book table, we say b. We join borrows as a relationship on book where book ID from the book side and borrow side are the same. And then we select a where condition where we try to make sure that there are certain ranges of date that match this time frame to this time frame, and we group it by the title and the ID. So we do it by both, by title and by ID. And then we order by total borrow count as descending order. And practically, this code is over here. We can copy paste it like this, like this. And in that way, we can further go ahead and see what happens if we start removing every single query. First, if we run this query without any problem, we see title of books and we see certain borrow count from to like highest to lowest descending order. Then if we remove this, if we remove the select clause, let's see what happens. It gives us error. If we remove the from, if it again gives us error. If we remove join, it again gives us error. If we remove where, then it works because we just get away with the condition. So it means it works even if we don't. So where is not a must. It's just a condition in this SQL code. Then we remove group by. It won't group it by anything. Then and if we get rid of order by, then of course it will. So order by, where, and group by are optional conditions, but these are important to fulfill the user story criterion because then the criterion is not fulfilled properly. And based on that, this is the user story number one. Then we know that join links each borrow event to its book where between filters to the window before grouping. Group by book.book ID b.title group by the primary key. So we use a primary key. Title comes along because it's functionally dependent on book ID. It's dependent on book ID. And then we cannot take book ID without the title. So book ID is dependent on is functionally dependent on title is dependent on book ID. So you cannot get the title without the book ID. You need the book ID. So it's dependency and it's perfectly fine. So then we have a count br.book ID counts rows per group, borrow count order by the descending ranks first, most borrowed first. Then we know that move the date filter in having instead of where, what changes. So where filters row aggregation, and having filters group after aggregation and can't see individual date, borrow date once grouped. Putting a per raw date condition in having would be wrong. Error. Use where for raw filters, having for conditions on aggregations. For example, having count bigger than 5. And we know that inner join is used, which books never appear. So books with 0 borrows in the window disappear. So no matching borrow raw. If story wanted it, because the user story doesn't work like that, but if the story was like including books borrowed 0 time, switch to left join, book borrows and count the borrow side keys, so nulls counted as 0. Then we would have used the left join so that the 0 comes. Then we know that borrowed books with email active checkouts. This is the second user story. So we select b dot title br dot due date s dot email from active loans br. We join books b on br dot book id, where it's equal to from books the book id. So the borrowed books are equal to the books that exist, and we join it with a student that borrowed the book and in general record of the student that we have, and we put it in ascending order. Now, because we used active loans, so we need to explain it that active loans basically is a view perspective. For example, if I was to say, okay, every new employee that comes in, like Sarah, David, and I might have to add him again to the email before sending it, or I might just send that at everyone, and then I might send it every time I have to write. I don't have to change this. That's the same thing for active loans. If active loans mean something different in the future, we don't have to change the logic again and create a different SQL code for it, because that creates more manual effort and long time. And this is a logical data independence. And if we say that where borrow return date is null, or we change something in the logic, we can still make it work. For example, view definition and is like a view in SQL. A normal view is not stored; it is expanded at query time. So we know this, that we can rewrite the user story against borrows with br return date is null. So we could we need to know this, or we can rewrite the query against borrows with where br return date is null. Now, why sort ascending on due date? We closest deadline first. So the librarian contacts the most urgent students first. So that's ascending, and smallest, earliest date at top. So it's the earliest date at top, so which is the most urgent. And then we have high demand genre. We will first try to run this user story real quick. Um, we can see that we have title, we have due date, and we have the email of people who have this. The thing with the user story was that borrowed books with email. As a librarian, I want to see the return due dates, and student email addresses for all currently checked out books, so that I can contact students before the deadline. So the deadline has not passed, but this is the deadline, and this is the due date, and this is the email. So I can already email them before this happens. Please try to return the book, because and then it comes the earliest comes first, and then comes like the later ones that are like less in danger. But the urgent ones are like the due date is like very urgent, and we try to contact them as early as possible through the email address that we have. Then what we did here is that we used, just like I mentioned, logical data independence, and the query perfectly worked. What could have also done is that we could have used borrows, but because borrows is an existing logic that we already have, in case active loans mean something different, where we need to include lost books, for example, we are trying to scale from a future perspective, that in the future, if the logic of act is from only a view, from a view perspective, it doesn't exist in the code side. So you might say borrows, and after saying borrows, you might select go, and then it will work perfectly fine because we are using the borrows table. But why is this not consistent, and why is this not a better choice? Is because in the future don't have that freedom of change where we can say, okay, we need a view. There's a concept called logical data independence from lecture number 1, and based on that, I use this concept for active loans in the view. Then we have a high demand genre. We need to know that we select, for example, we say, okay, select the user story number 3 is high demand genre. As a librarian, I want to see which genres are the most borrowed, so that I can order more copies of those genres. Um, Meaning that select g.name as genre name, count br.book id as total borrow count. So what he does that is selects the from the genre table the name as genre name, and it takes the count from the borrows book ID as this new variable. And then from genre, it makes like a new variable, just like I said. And we did, you can notice we did a left join. And why we did a left join? Because it will also give the zero in return if it's a zero. That's why it's a left join. So we can have all the information and we don't lose any information. We did left join book genre bg on g dot genre id is equal to uh, book genre id. So from the genre, on this book genre, it's we try to make this the same, and then we try to make sure that if that is a join, it's a matching condition or borrows table, where the br on the bg here book genre dot book id, where book id are the same on borrows and book genre situation. So basically we try to compare these two conditions together at the same time and check and join them together with a left join, and we categorize them, group them with the genre ID and genre name, because genre name is dependent on genre ID. Only then we can group it that way, and then we can order it in descending order. Let's try to run this user story. But first, wait a minute. We can also start join. If we remove join, if we remove any of these joins, it will give an error because join is a must. So, and if we remove this join as well, it will give us error. But if we remove from, let's see what happens then. It again gives us error. So here we don't have any optional except for order by. We know that if we remove this, it will just not order it by a specific rate. It will just give us randomly. Um, but and if we get rid of select, it will again give us error because it's not okay. Then we have we understand this that in user story number 3, we have understood that the chain we have genre is book goes to book ID. The bridge, because we have many to many bridge, we use borrows. So two left joins keep genres that have books but no borrows, and even genres with no books, showing a count of zero. So even if we have genre with no books, it will still show us because we used a left join. And count br dot book ID, not count asterisk, so unmatched left join rows null count as 0, not 1. So the story is about which genre, is about genre to stock more of a genre with 0 borrows is meaningful candidate to drop. So it must not vanish. So left join prevents the left genre side. If you only care about the genres that were actually borrowed, inner is fine. So it depends on our user story case, but in our case, this is why we did it. Now we have the story number 4. We have overdue book tracking. As a librarian, I want to see which students have overdue books and their unpaid fines, and that I can send them a reminder email. And now, because they have overdue their fines already, back then it was just like it was close maybe, and now this has already happened. And now we try to run this story first and see what happens. We see the name of the person, email of the person, title that he took, the due date that has passed, and the fine amount that we have now. Now, what happens is that we see the query box, we see that we select the name as something different. Then we say select email and title as book title. Then from the borrows, we might say due date, and we have a date difference function. What it does is that it's current date minus borrow due date. So it does current date. This will be our current date, for example, and this will be from the borrows the due date. So when it gets subtracted, we know the difference, and The bigger the difference, then we know we need to multiply with a certain amount as fine amount. Once that happens, we can, from the borrows table, we join the student, where student from the student table, where the ID of the borrowed student and the student itself is the same, and from the book table, the book ID, where the borrowed book and the book itself is the same, and where the return date is null, and the the borrow date is less than the current date. So after once all of this happens, we get this result. Then we can say, okay, let me try to remove where. Where will it will still work without the where, because where is just not that important. It's just doing a where situation. Joins are always important. You cannot get rid of any join, and it will give you an error. The same applies to this join. It will give you error. And that's the same thing for from. If you remove this and you run this, it doesn't work. And that's of course the same thing for select. You're making everything, but what are you selecting it? And that was about the user story number 3. Oh, sorry, user story number 4 actually. So the person has already surpassed the fine time in this situation. Then we have free up library space. As a librarian, I want to identify books that are never or rarely borrowed. I can give them away to free up some space. And what happens in that case is that I might go ahead and try to run this user story, find the books that are never borrowed. Then we know, okay, title, author, copies, and total count is 0. And we know that, oh, these are never borrowed. These are never taken. Now we see that we take the title and we take the name as author name from name of the author. Like if we ran this story, we got title, we have author, we have number of copies, we have borrow count. But what's important to see is that we select count all from copy, where copy is this, like the copy is the same, the copy is the same as book ID as number of copies. So we know these are the number of copies that we got. And from borrows, we extracted and the total borrow count. And this is of course the borrows, and this is the actual book. So we know that once these books are borrowed, this will come out as this variable. Then we understand this, that there is a join connecting these two conditions. Book ID, where the book author ID is the same as the book itself, and the author ID is the same as the book author. And here we know that once these things match, we will get the perfectly layout version of title, authors that are borrowed. And then we did a clever technique to say, okay, total borrow count is ascending. So reversed it. So the least comes first. Then we go, and then we only get 0 at first, and then we don't get. If we were to do that, then we would generally get more of these. But because we did an ascending one, we will eventually find one that is there, but that we have to go very down in that case. But it works perfectly for our use case because, okay, they say this, the user story 4 was like return date is null, not returned yet, active, due date is less than current date, past deadline, both together overdue. So deadline, current date and due date both pass. Then we have date difference, current date minus due date, multiply by 0 computes the current running fine. So its current running fine is 0.50 euro a day. So the more the current date goes, the more the current date increases, we have a higher number. Then the more days goes up, we have the days that of the current date, and then we have days of due date. Once those 2 days keep increasing in number, this we multiply it, then we have higher, for example, 0.50 euro a day. So we store fine amount in borrows, yet here I recomputed. We have two versions. We have the stored fine amount is the final charge value written when the book is returned, audit record, for example. This query is a live projected fine for books still out, no return date yet, so no final fine exists. Different purposes, snapshot versus live estimate. So we have section 8 explaining this even further. Then I have select B title author dot name as author, and then select all from copy where copy ID book ID is the same as borrow book ID as number of copies, and just like we explained the entire code. So uses correlation queries, each run per outer book row referring to book ID from outside order by ascending, puts zero lowest at first and strongest giveaways that can be great. We without subqueries, yes, left join copy and left join borrows, then count distinct C dot copy ID and count distinct BR row. Watch the fan out trap, joining both copies in row multiple rows, so you must use count distinct or the count inflate. That's exactly why subqueries are cleaner. The good thing to volunteer. Then we know that a co-authored book, what happens to this in the query? The inner join through book author makes it appear once per author, duplicated rows acceptable for this report, but we need to note that group concatenation author plus group by book would collapse in one row. Then we have the ER model relational schema. We have strong entities have their own table, attributes become columns. These attributes, they become the columns. The entity key become the primary key, student key, author, genre, weak entity, its own table. So primary key is the owner's primary key plus its own partial key. Owner primary key is also foreign key. So for example, copy has a primary key book ID, copy ID. This is used as a composite key. From one to many relationship, we don't need a table. So we put the PK of the first side as a foreign key and the n side on the n side. So on the other side, we put it as a foreign key. So book 1 to n copy, book ID sits in copy table. Then we have many-to-many relationship. New bridge table is needed, whose primary key is combination of both primary foreign keys. Book author, so book genre, one-to-one foreign key on either sides with a unique constraint or merge into one table. Then we have relationship attributes live on the foreign key holding table, one-to-many or on the bridge table, many-to-many borrow date, due date, fine amount, lives in borrows. And we have multi-valued attributes, its own table, for example, composite attributes split into atomic columns. Then we have book has copy, one-to-many, foreign key, book ID inside copy. We have no bridges because we don't need one in that case. Book has author, many-to-many authors. Bridge table, we have book author table. That's a bridge between this book that uses book ID and author ID. We have book has genre, many-to-many. Then we have book genre bridge table, which uses book ID and genre ID. And we have student borrows copy, many-to-many plus attributes. So we bridge table is borrows with loan attributes. So this is the table. Now, why student borrows copy a table, but book copy is not? So book copy is one to many. So a single foreign key captures it. A book points to one book. Student copy is many to many. A student borrows many copies over time. A book is borrowed by many students, which is a single foreign key cannot express. You need a bridge. So it also carries its own attributes, which forces a separate relation regardless. Then we have reconstruct the primary key from the ER model. Then we know that it connects students and the weak entity relation and the weak entity copy. So it inherits student ID plus book ID and copy ID, but the same copy is borrowed repeatedly. So those alone aren't unique over time. So we add borrow date. Final primary key is equal to this student ID, book ID, copy ID, and borrow date. The foreign key to copy is the composite key, book ID and copy ID. We need to use this composite key for it to work. Then you can change the book author to one to many. A book has exactly one author and we redo it. Then we say then the bridge disappears. We drop book author and put author ID as a foreign key column inside book. This is exact change the cardinality, change the tables, move move they love. Be ready to do it both directions. Then we have cardinalities and three notations. We have Chen notation, one or n on the relationship edge read towards the far entity. One student has many exams, one exam has many students. So it's just one time you write this. It states the look across max cardinality. Then we have min-max structure notation, writes in pair, min comma max. So we have describing like this. And then for example, read 1 comma 1 or 0 comma many copies allowed in different directions. Copy aside 1 1. Each copy belongs to exactly one book. Mandatory single book sides 0 to many. A book can have 0 to many copies. This asymmetry is why the foreign key goes on copy side. And then we have keys, we have super key, any attribute sets that uniquely identify a row. For example, student ID comma name in the student. A candidate key is a minimal super key, no removable attributes. Email, for example, in student. Primary key, the chosen candidate key, not null unique. And we have student ID, book ID, genre ID, for example. And we have a composite key, a primary key made of two columns. For example, a copy has two book ID and copy ID. We use them collectively to make a composite key. A primary key made of two plus columns. This is a composite key. Foreign key is column referencing another table. Primary key enforces referral integrity. So borrows student ID. Here we have this is from students, so it's a foreign key from students. We use it here in a different table. We have surrogate key, artificial ID with no business meaning. Um, Author ID is a surrogate key. It has no business meaning. Genre ID is also a surrogate key. It has no business value. We have partial discriminator key, weak entity's own key, unique only within its owner. So copy ID within a book. It's weak. So why each surrogate key are introduced? So book title rejected as key. The data set has two different editions, both called the metamorphosis. So title isn't unique. So we need to use book ID because the title could be same for many books. So two real authors can share a name. First name, last name could be same. So we use a surrogate key, author ID. And for students, name not unique. Email is a candidate key but can change in time and is bulky. Introduce student ID as a primary key. So we keep email as a candidate key and unique key. Then we have copy. A physical copy has no identity outside its book. Copy number one of book A is not equal to copy number one of book B. Then we have a composite primary key, book ID, and copy ID. This works together with each other to function properly. Then we have email is unique. Why isn't it the primary key? It's a valid candidate key, but primary keys should be stable, simple, and never change. We have emails change and are long variable. They're poor for foreign keys, referring it everywhere. So we pick a single stable surrogate like student ID as primary and can still put put a unique constraint on email. What makes copy a weak entity exactly? There are two things. First, existence dependency. A copy can't exist without owning a book. So, what is a copy without a book? Like there is just a book, it's a copy of a book, right? No key of its own. So, copy ID only makes sense relative to a book. Its primary key therefore borrows the owner's key, so book ID and the copy ID, drawn with double rectangles plus a double diamond in Chen notation.